Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our fourth lesson on scale drawing, whereby we are looking at a question on survey. So example 4 reads that the measurements of a coffee field were entered in a field book as follows. Taking xy, which is equals to 400 meters as the baseline, use a scale of 1 centimeter to represent 40 meters to draw the field of, to draw the map of the coffee field, hence find the area of the coffee field in hectares. So I'm going to obtain a sketch. So to draw a sketch, you usually start with the baseline. So we are told that the baseline is to use xy as our baseline. So this is x, then of course this is y, which is actually 400 meters. So I'm going to start with remember, coordinates on this side represent the lower side, or this one will go to the downward side of this particular line. Then coordinates on the left hand side will go to the upward side of the baseline, which is xy. So from point X we are going to move 100 meters, which will take us to another point P. So from here we are supposed to move 100 meters. So this is the 100 meter mark, which will take us to point P on the downward side. So from this line we need to move 200 meters to the downward side, which will take us to another point P. Then from P we'll move up to the 200 meter mark. So assuming our 200 meter mark is here, it should take us to the upward side 160 meters to point S. So from the 200 meter mark, it should take us to point S, which is 160 meters from the baseline. Then from the 200 we'll move up to 280 mark. So this is the 280 meter mark, which will take us to the upper side to point R, which is 100 meter from the baseline. So this one should be to point R. So the distance is 100 meter from the baseline at the 280 mark. Then from there we are going to move to 360. So this is the 360 meter mark, which should take us to the downward side to point Q. So which is 100 meters. So this is 100 meters to our point Q. Then of course once we get Q, we are going to connect them to the points, of course, X and the point Y. Then we need to use our scale. We are told to use a scale of 1 centimeter to represent 40 meters. So we need to convert all these values. So what about, we can start with 100 meters. So that will be 100 over 40 meters multiplied by 1 centimeter, which is going to give us 100 divided by 40. You are going to get 2.5. So it means here we are supposed to measure 2.5 centimeters. So this should be 2.5 centimeters. Maybe let me use a different ink. Then 200 meter, it will be 200 divided by 40, which should give us 5 centimeters. So here we'll measure 5 centimeters. Then to 200, of course it will also be 5 centimeters. Then 160 divided by 40, 160 over 40, you're going to get 4 centimeters. So here we need to measure 4 centimeters. Then here we have up to 280. So 280 divided by 40, you're going to get 7 centimeters. So here we need 7 centimeters. Then 100 divided by 40, you're going to get 2.5. So here we need 2.5 centimeters. Then up to 360 divided by 40, you're going to get 9 centimeters. So here we need to measure 9 centimeters. Then 100, of course, will still be 2.5 centimeters. Then from X to Y, it was 400 meters. So 400 meters divided by 40, you are going to get 10 centimeters. So it means here we need to measure 10 centimeters. Then of course this is the starting point, which is the 0 centimeters. So that is the sketch that we are going to use. Therefore, we are going to draw it to scale. So we are going to start with the baseline, which we have seen from point X to Y. We need 10 centimeters. Therefore, I need to measure 10 centimeters from this particular point here. So let me draw my diagram at this particular point. So I need a line which is 10 centimeters. Then I can use, with the help of my pair of compass, I can simply measure the 10 centimeters so that I see where they are going to fit. So this is my 10.2, 10.0. So 10 centimeters will fit on this particular scale. Let me just rotate it. Actually, it's a smaller diagram. So 10 centimeters. So let me ensure that it is aligned well. So with the 10 centimeters, so my 10 centimeters are around this point here. So this is my baseline. Then with the same 10 centimeters, I'll also transfer it to this point so that I also see where the 10 centimeters fit on this other side. So this is our 10 centimeters. Therefore, it means that we already have the coordinates of X and Y. So this is point X, then this will be the point Y. Then from the point X, we need to measure from here to this particular point. The distance of 100 meters is actually 2.5 centimeters. So let me see where the 2.5 centimeters will fit. So 2.5 will be at around this point here. So this is 2, so 2.5 will be exactly somewhere here. So let me draw a line to fit that particular point. So my 2.5 will be through this point here. So remember, we need the line to move to the lower side up to the 200 meter mark, the 200 meter mark. So I'll draw my line from this particular point here. This is the 2.5 centimeters. So my 2.5 was around this point, so I'm going to connect it downward. Then ensure that the angle is strictly 90 degrees. You can use your protractor to confirm that. Ensure that the angle to the lower side is 90 degrees. The way you are seeing mine is exactly 90 degrees. Then of course, on the lower side, we need to measure 200 meter, which is equivalent to 5 centimeters. So let me use this. I need 5 centimeters, 5.0 centimeters. So these are my 5 centimeters. So I'm going to pick it through this point, the point on the baseline. So through this point, I need exactly 5 centimeters. Yeah, this is 5.0 centimeters. Then I simply make an arc on this particular line where the 5 centimeters fit. Then we are going to move to the next point, which is 200 meter from the baseline. So you also need 5 centimeters. So from this particular baseline, I'm going to measure 5 centimeters. Remember, this one is already 5 centimeters. You can see it's 5.0. So 5 centimeters will fit at this point. That is the 200 meter mark. Then from here, we need 4 centimeters on the upper side. 4 centimeters on the upper side. Therefore, let me reduce this to 4 centimeters, 4.0. Then I'm going to transfer it to this point. So when it is 4 centimeters, I am going to make an arc on the upper side. It should be exactly 4.0. Yeah, 4.0 is there. So I'll make an arc on the upper side. Then of course, you can use your protractor to ensure that this angle is 90. So you just connect these two. So that is point S. Then point R, we need 7 centimeters from the point X. That is the starting point. That is the 280. So 7 centimeters from the starting point, which was point X. So that is our point X. So I need 7 centimeters, 7.0. So that is my 7.0. Then I'm going to make an arc this way. So we are at this point. Then we move to from the 7 centimeters, we are supposed to move 100 meters to point R on the upper side. Of course, 100 meters is represented by 2.5. So I can simply use my ruler to see where the 2.5 centimeters will be. So 2.5 from this particular point, I need 2.5 centimeters. So let me align my ruler. 2.5 is at this particular point here. So with the 2.5 I can actually use my that is 2.5. So you can see the 2.5 is at around this point here. So this is where I'm having my 2.5. 2.5 is here. Then of course I need to draw a line connecting through up to where the 2.5 is. So the line from this particular point up to the 2.5. So you can see the 2.5 is exactly here where the dot is. So that is my 2.5. So that should be point R. Then we move to this point, which is 360 meters, which is 9 centimeters. So let me ensure that my angle is actually, that is the distance is 9 centimeters. 9.0. So this is my 9.0 centimeters. It is at this point. So I'm going to make an arc. So that is then to point Q, I need again 2.5 centimeters. So 2.5 centimeters, but now on the lower side of this particular line. So my 2.5, let me align it. My 2.5 is at this point. So this is my 2.5 in between 2 and 3. So this is 2.5. Then of course, using your ruler, then of course your protractor, ensure that the angle is 90. So from this point up to 2.5. So this is where my 2.5 is. So use your protractor to ensure that the angles are, the distance is 90. For example, this one is not 90. So let me redraw this line. You need to ensure that it goes through the 90 degrees. It must be strictly 90 for you to get accurate results. So let me draw my line from this point. 90. It must be strictly 90. Yeah, 90 is passing through this. So 90 should go through this point here. Let me also verify whether the ones that I've drawn here are 90. This one is let me remove this. I need to ensure that it's exactly an angle of 90. Yeah, this one is 90. I can also verify the upper one. Let me see. If the angles are not 90, you are not going to get the accurate results. So ensure the angles are 90. Yeah, this one is 90. This is also 90. Good. Then from there, you are going to label the points, and of course you join. You join them to the baselines. So let me first of all join. So I'm going to join. So X should be joined to the first point, which was P. So I'll join X to point P. Then after that, you join P to. So P should be joined to the next point on this side, which is point Q. That is this point here. It must go through where the dot is. Then after that, point Q should be joined to point Y. That is the starting point this way. Then of course Y should be joined to point R on this other side this way. Then of course R should be joined to it should be joined to this other point here, which is our point S. Then point S should be joined to the starting point, which was our point X. So that is the field that is expected to be drawn. So that is our field. Then having drawn the field, we need to label the coordinates. So these are our coordinates. Let me label them. So this was point X, which is already labeled. This was point P. Then this is a point, from point P we have point Q here. Then from point Q we have point R on this side, so this is our point R. Then from R we have point S on the upper side, then back to the starting point, which was our point X. Now we can go to answering other questions. So let me remove the sketch because it has already helped me to draw the accurate diagram, which is to scale or the field. So we are told to, taking XY as the baseline, which is 400 meter, use a scale of 1 centimeter to draw at the field. So this is our field. Then hence find the area of the coffee field. So to find the area, you can subdivide the field into different shapes. So this is shape A. So I'm going to label this one my shape A. Then this one to be B. This one to be C. This one to be, of course, this one to be D. Then this one should be E. Then this one will be F. So to find the total area, we'll find the area. So total area will be equal to the area of A. So area A. Then of course we add area B, the area of B. Then we add the area of C, area C. Then we add area D, then we add area. We also add area E, then of course area F. So the sum of those areas should give you the total area. So the area of A, the shape of A is actually a triangle because this is a 90. It's a right angle triangle. So this one should give us a half base times height. So a half multiplied by the base. The base was the distance from this point up to this point here. So that is the distance from X to our point S. From X to S, so this is X, up to point S we had 200 meters. So this distance is 200 meters. So our base is 200 meters. Then multiplied by the height. The height is the distance from this point up to S. So the distance to point S was 160 meters. So multiplied by 160 meters. Then we add area B is a trapezium, which should give us a half into A plus B times height. So our A, remember A and B are usually the parallel sides. So this side and this side are the parallel sides. So the distance from this will be our A, then this one will be the side B. So A is the distance to point S. The distance actually to point S will be our A, which is still 160. So this should be 160 meters. Then you add our B will be the distance to point R. So R was 100 meters. So 100 meters. Then you add, we move to, so we are through with area A and B. Then of course, remember the area of the trapezium is a half into A plus B times height. So we are supposed to multiply with the height. So the height will be this distance here, the distance between the parallel sides. So the height will be the distance between point S and R on the baseline. The distance between S and R. This distance here, which is 280 minus 200, which will give you 80 meters. Then you add, we move to area C. Area C is also a right angle triangle. Of course, this is the 90. So this will be a half multiplied by the base will be the distance from R to Y on the baseline. The distance from R, which is 280 to Y. Remember the Y was 400 meters. So that distance from point R to point Y will be 400 minus 280. So 400 minus 280 is going to give you 120. So that means our base is 120 meters. Then times, remember 120 is from R up to Y. So the R, the base of R is 280 up to Y, which is 400. 400 minus 280, you get 120. A half base times the height will be the distance to point R, which is still 100 meters. So times 100 meters. Then we are also going to add. So we add, so that is area A, B, and C. So we move to area D. So D is also a right angle triangle where the 90 is here, which will be a half base times height. So a half times the base will be the distance from Q to Y. So Q is 360 up to Y is 400. So if you take 400 minus 360, you are going to get 40 meters. So the base is 40 meters. Then times the height will be the distance from here up to point Q. So to point Q we had 100 meters. 100 meters. Then you are going to add. We move to area. So this is area A, B, C, D. So we move to the area of E. E is a trapezium because these are the parallel sides, this one and these. So it will be a half into A plus B times height. So A and B will be the parallel sides. So parallel side, one of it is the one going to point P. So point P we had 200 meters. So 200, then we are going to add the distance to Q. Q was 100 meters. So plus 100 meters. So 200 plus 100 meters. Then times the height will be the perpendicular distance between the parallel sides, which will be the distance on the base from point P to Q. So point P was 100, then Q is 360. So that distance will be 360 minus 100, which is going to give you 260. So the height is 260, that is 360 minus 100. Then plus, we move to area F. Area F is a right angle triangle where 90 is here, so it will be a half base times height. So of course the base times height. The base will be the distance to P on the horizontal line. The distance to P is 100, so this will be 100. Base is 100 times. The height will be distance from here up to the upper part, which is the distance to point P, which is 200 meters. So this should give us, so if I compute the first part, so the first part is a half, which is 0.5 times 200, then times 160. This one is going to give me 1600, because this one will go here 1, this one will go here 100 times. So this is 16, actually it will be 16,000. If you multiply 100 by 160, you get 16,000, because we have 3 zeros. 16,000. Then you are going to add this other part will be 160. I add to 100, then that will give me 260. I multiply it by 80, then I divide by 2. I'm going to get 10. So this will be 10,400. Then plus, I move to this part. Let me actually verify whether it is that is 160 plus 100 is 260 multiplied by 80, then divided by 2. The answer is 10,400. Then I'm going to add this other part, which is 120 multiplied by 100, then answer divided by 2. I'm going to get 6,000. Then 6,000, I'm going to add this other part is 0.5, then multiplied by 40, 0.5 by 40, then by 100. I'm going to get 2,000. So this is 2,000. Then I'm going to add this part, which is 300 multiplied by 260, then answer divided by 2. I'm going to get 39. So this is 39,000. Then the remaining part is this one will be 50 times 200, 50 times 200, which is going to give me 10,000. So this is 10,000. So if I add the whole of this, I'm going to have 16,000, then plus 10,400, then plus 6,000. Then I'm going to add 2,000. Then I'm going to add 39,000. Then I'm going to add 10,000. So the answer is actually 83. So I'm getting 83,400 square meter, because that is area. But they wanted the area in hectares, and we know that 10,000 square meter is equals to 1 hectare. What about 83 400 square meters. So this will be over 10,000 then multiplied by 1 hectare. Therefore the answer will be 83,400 divided by 10,000. You'll get the answer as 8. So I'm getting 8.34 hectares. So these are hectares. So thank you very much for accompanying me until the end of this particular lesson. I did not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time.